Today we're going to talk about the special products. These are the possible special products that we can use. First, we have the binomial to the square that gives us a perfect trinomial to the square, and then we have the conjugated binomials that give us different of squares, and then we have the binomial to the cube that gives us a perfect polynomial to the cube, and then we have binomial times a special trinomial that gives us difference of cubes and addition of cubes. Here is our problem, and we're going to look for a formula that fits on our problem. Our problem is 2 to the square, and the formula that has everything to the square is the binomial to the square. So we're going to apply this formula in our problem. We have our steps. First of all, we're going to find a and b, x plus 4 as a and minus c plus 3 as b. So in our problem we have 4 terms, and in our formula we have 2. So to make it fit on our formula, we add 2 terms on each letter. And we also add the minus, because if we apply the plus times minus, it's like if we have the positive in here and we just add the negative in here. Then we're going to substitute the formula into the values of a and b. So as we can see here, we add x plus 4 to the square, like in the formula, and then 2 plus a plus times b plus b to the square. We have 2 terms in which we can apply also the same formula, so we're going to follow the same steps because these ones are binomials to the square. Here we also apply the same formula, and so we found a and b, and then we substitute in our formula, and here are our results. We have here our results, but in our problem. Here we apply FOIL, that is first terms, outer terms, inner terms, and last terms. First the f, and we have x times minus c. And then we have the O, that is outer terms, and it's x times 3, and then the inner, that is 4 times minus c, and then the last terms, that is 4 times 3. So the answer that we have here, we're everything going to multiply times 2. Final answer of FOIL is this one, from this to here. And so we're done. We are just going to check if we have common factors. If we don't, we are done. Common mistakes are that in our procedure we can also have special products like we did it here, and another one could be that we don't apply properly FOIL.
Hi, so now we're going to do multiplication of radicals but with different index. Here we have the radicands, and these are the index. So now we're going to find its perfect squares and its perfect cubes. To find its perfect squares, here the only perfect squares we have are 4 and c to the 4th. So the perfect square of 4 is 2, and the perfect square of c to the 4th is c to the square. And now we leave these as the same. To find the perfect cube of all of these radicands, the perfect cube of 8, it's 2, because 2 times 2 times 2, it's 8. X to the 7th, it's not a perfect cube, and y to the 4th is not a perfect cube. C to the 6th is a perfect cube, which is z to the square. So now we quit the square root, and we put parentheses with the x 3 divided by 2 and y to the 5th divided by 3, because it's exponential form. It's these exponents are bigger than the index, so we have this as its exponential. Change it into exponential form, so the exponents are denominators and the index are the denominator, so we get 7 divided by 3 and 4 divided by 3. The exponents of the x's and the y's, and we're going to need to find its perfect denominator, which is 6, and these give us 23 divided by 6, and also the y. Now that we have this same denominator, now we can add denominators. So 14 plus 9 gives us 23 divided by 6. Now we're going to do the same thing with the y's. We're going to add the exponents. Now 5 divided by 2 plus 4 divided by 3. We have to find its common denominator, which is also 6. So we're going to do the same thing as we did in the x, and we get 23 divided by 6. So now that our exponents have the same denominator, we now multiply 2 times 2 give us 4, and c to the square times c to the square gives us c to the fourth. Now the 6, since they have the same denominator, the 6 becomes the index, and we now have x to the 23 and y to the 23. Now, common mistake that we can do is not knowing how to get the perfect squares or the perfect cubes of a number.